Hello and good morning, dear students. So today is 24th of August, and in the last class we started homogeneous differential equation. We even did question number 3 part 1 and part 2, right? So we are doing exercise 9.6. Now if I move to question number 4, 5, 6, 7, now this question is obviously based on homogeneous differential equation, but the problem out here is after solving it, we will be coming into that particular step where we have to use standard integrals. I hope you understand my point. Where we have to use standard integrals of different types, and those standard integrals has been reduced from the syllabus. Okay, so that is the problem why we can't do question number 4, 5, 6 and even 7. Okay, because this year we know, because of the pandemic, coronavirus disease, the syllabus of ISA has been reduced, and the main part of integration has been reduced. If you see the syllabus, you'll come and understand. Please compare the reduced syllabus which I have sent you in WhatsApp as well as your normal syllabus of class 12. Okay, the portion of integration has been drastically reduced. So the major topics of integration has been reduced, so which we have to use out here, isn't it or not? So we will not be able to solve this question because we have not done that standard integrals. Clear? And so therefore 4, 5, 6, 7 not possible. I want to go to question number 2, just a few questions so that to make it clear the concept of homogeneous differential equation. Like in question number 2, which of the following differential equations are homogeneous? For example, if I go to question number 1, part 1, the question is x minus y. Please just understand this, you don't have to do it in your copies, right? Which is equals to x plus 2y. I've told you the process or the steps to identify whether it's homogeneous or not. Either you can go by lambda process, either we can simply look at the powers in numerator and denominator. Correct? Okay, so if I see the power of x 1, power of y 1, in between there is addition sign, so hence the power for the numerator is 1. Similarly, the power for denominator is 1. The powers are equal, so hence it is an HDE. So this is one of the easiest method to identify whether a differential equation is homogeneous or not. Okay, so I want you all to go through question number 2 part 1 I have already done. Please try question number 2 part 2. You can take dy dx common out there. 2 part 3, at least part 4 until part 5, so that your concept of HDE will be clear. Any problem you can ask me in WhatsApp. Clear? So now we move to question number 8 then. We move to question number 8. In question number 8, the question is solve the following differential equation. Question number 8 part 1. Okay, number 8 part 1 is x into dy by dx plus y square by x, right, is equals to y. Let us first simplify this differential equation and also check whether it is HDE or not. Okay, so therefore this implies x into dy by dx. We know the process. Let's take this side. So y minus y square by x. Let us take x as the LCM, right? So therefore if I take x as the LCM, this will be xy minus y square, alright? And I can also cross multiply with x, so therefore dy by dx will be xy minus y square divided by x square. Now let us check the powers. Okay, x1, there is multiplication, so I have to add the powers. x1, y1, so what is the power? 2 minus the power is already 2, so the power in the numerator is 2, the power in the denominator is also 2, so hence let's keep it equation 1. Here equation 1 is a homogeneous differential equation. So we have identified, yes, it is an HDE. So pause the video, note it down till here. Alright. Okay, so therefore it is an HDE. Once it is an HDE, then we know the substitution y is equals to Vx. differentiate with respect to x. Remember that v is also a function of x, so we have to use u into v rule. V ddx of x1 plus x ddx of v is ddx of v. Okay, so we'll put the value for dy by dx out here quickly in equation number 1. Therefore, we will be getting, in place of dy by dx, it is v plus x dv by dx, which is equals to x. What is the value for y? Vx. So hence it will be vx square minus v square x square divided by x square, right? So therefore v plus x dv by dx, which is equals to x square common, so v minus v square divided by x square. Now we know what to do. Let us cancel x square, so therefore v plus x dv by dx, which is equals to v minus v square plus v minus v cancel out. So now I can do cross multiplication, that is dv by v square is equals to minus dx by x. I hope you are clear till here. This by this is equals to dx by x, cross multiplication. Okay, so pause the video, note it down till here. Alright, so now the variables have been separated. Once the variable is separated, we can do integration both sides. V to the power minus 2. So v to the power minus 2 dv, please take the integration, you'll be getting this, minus log x plus constant, minus 1 by v. The value for v from here, y is equals to vx was the substitution. So v is equals to y by x, that will be x by y, minus log x plus c. And keep it in here, in a simplified mode, it's up to you. Okay, so please pause the video and note it down. Okay, let's move to question number 8 part 2. Number 8 part 2 is x and dy by dx. So I've done the cross multiplication right here. Let us see, the power is 1, the power is 1, and there is multiplication, but they are inside the bracket, and there is again logarithm. Okay, so the power remains as 1, 1, and it does not matter. If it only is y into y or y into x, then the power will be added, but out here it is log. So hence the power throughout the numerator is 1, the power in the denominator is also 1, alright? And yes, it is an HDE. Let us keep it as 1. Here, equation 1 is a homogeneous differential equation. So again the same, let y is equals to vx. So dy by dx is equals to v plus x dv by dx. Alright, so from equation 1, the value for left hand side dy by dx will be v plus x dv by dx, which is equals to y vx. So v into x within the curly bracket, y vx minus log x plus 1 divided by x. What happens is x and x gets cancelled out. Okay, so I'm doing it this side now. This is equation 1. Okay, so therefore v plus x dv by dx. Alright, so this is v. Now the denominator has been vanished. So log vx, that is log v plus log x. Alright, log v plus log x minus log x plus 1. So out here plus log x minus log x gets cancelled out. So v plus x dv by dx is equals to v into, this is log v, here plus log x minus log x gets cancelled out, so plus 1 only. Let us multiply with v, so dv by dx, this is v log v plus v, right? So now plus v and plus v again gets cancelled out. So please pause till out here and note it down. Alright, so here plus v gets cancelled out, so hence I'll be getting x dv by dx is equals to v log v, and now I can do separation of variables. Dv by v log v is equals to dx by x, and now let us take the integration on both the sides. So therefore, and this we have to do a substitution, so I'm keeping it as I1 and this is log x. Let us keep it as equation number 2. Now how to do equation I1, I'll tell you. Okay, Alright, so therefore, now please come back out here. I1 equals to log x. Now I1 means 1 by v log v into dv. Now we know how to do this. Please substitute log v as any other variable I have taken as u. So u equals to log v, differentiate with differentiate with v. So du by dv is equals to 1 by v, because differentiation of log v is 1 by v. Cross multiply dv by b. So dv by b is du. So therefore I1 out here, I1 integration dv by v. dv by v means du. So dv by v will be du, and 1 log v is u. So this will be du by u. Please be clear with this. Alright, don't get confused. Log v means u, and dv by v means du. So it is only du by u. So integration of du by u means log u. And what was u? U means log v. So the final answer of I1 will be log v. Right? So therefore, in equation number 2, from equation 2, the value for I1 is log v, which is equals to log x plus, and I am writing any constant. Instead of writing c, I am writing log c, because c is a constant, log c is also constant. On doing so, I will be getting log v is equals to log x into c, because log a into b is log a plus log b, right? Log we can remove, so it will be only log v is equals to x into c. Alright, so what was v? Y by x. Log y by x is equals to x into c. So you can keep it till here, or you can also write in the form of exponential, because it is e out here. Log of y by x is equals to e to the power x into c. So anything is okay, the answer might be anything. You can also write this as, see, log of something equals to xc means y by x is equals to e to the power xc. So I don't know what is the answer at the back. So anything is your answer. Okay, this is also your answer. Either this is your answer, or either this is also your answer. Okay, so please pause the video, note it down. Alright, let's move ahead. Question number 9, part 1. Now, question number 9, part 1. The question is dy by dx is equals to y by x plus root x square minus y square divided by x. Okay, so if we can first take x LCM, take x as LCM, you'll be getting y plus this. Now, I have written out here, this is an HD. I'm explaining why. X to the power 1, so the power in the denominator is 1. Y to the power 1, the power in the denominator is 1. There's a plus sign. Now, x square, y square, but it is inside the square root. See, x square, y square, it is, whenever it is inside the square root, you have to think, square and square gets cancelled out, the power is again 1. So hence it is an HDE. Okay, once it is an HD, the same thing, y is equals to Vx. So when y equals to Vx, we get this. I have kept as equation 1. Put the value for dy by dx as this in equation number 1, and wherever it is y, you replace it by Vx. So in doing this, you'll be getting this. Simplification, x square common. If you take x square common inside the square root, and if it comes outside of the square root, it will be only x. You can take x common, which gets cancelled out. So hence I'll be getting v plus x dv by dx, which equals to v x1 plus root 1 minus v square. The next step, again, v and v also gets cancelled out. V and v gets cancelled out. Now we have to just do separation of variables. So I'm clearing this. As well as this. So therefore, from here, I will be getting, you can cross multiply dv by root 1 minus v square is equals to dx by x. It has been separated, so I can use integration. Alright, I hope you know this. Integration of, this is root over a square minus x square dx, sine inverse x by a sine inverse x by a plus c, right? So hence the same thing out here, but sine inverse x by a means 1. So sine inverse v is equals to log x plus c. Finally, we'll put the value for v as y by x. So this is log x plus c. Okay, so please pause the video, note it down. Alright, so I hope you're clear with this. So today's homework I'm giving you is question number 9 part 2 and number 10 part 1. Please do complete all the sums of today's class as well as complete these two questions and submit it by tomorrow. Okay, and I've also told you this Saturday your open book test number 2 will be of chapter differentiation till second order derivative. Till your second order derivative. Okay, so that's it for today. I'll see you tomorrow in the next one. Take care.